Assalamualaikum warahmatullahi wabarakatuh. Very good morning to Dr. Faisal. So today I will present about my mini project for flight mechanics. So my aircraft model is Cessna Citation X Plus. So in today's presentation, I will present about mission profile, steady flight performance, and accelerated flight performance. So first of all, about the mission profiles. So in these assignments, as I mentioned earlier, Cessna Citation Express was chosen to do missions traveling starting from Kuala Lumpur to Abu Dhabi. So in this mission profile, there are basically 6 checkpoint or point that I will assume. So for the first to second points, I will calculate the takeoff distance, and second to third point, there are some analyze about the climb rate, and at the 3 and 4 points, the cruising started, and I will calculate the range, maximum range, and for the 4 points, there are some endurance, and if they are containing remind they are containing fuel, so my aircraft will do some loitering, and then lastly I will calculate about the landing distance. So first of all, about the steady flight performance. So at steady flight performance in my projects, I will estimate the aircraft thrust at cruising. So as you can see in this slides, I will apply all of this formula and put it the value in this formula to get the polar drag. So first step to calculate the thrust is I calculate the polar drag, and then I substitute in thrust equation, and for thrust at steady flight I get 8.97 kilonewton. So next, for the maximum range, I use this formula and apply it to, and my maximum range for the Cessna Citation Express is 3771.2 miles. So basically, this range are near to the general Cessna Citation X aircraft in internet. So next, for the maximum endurance, I get 12.2 hours, and so my CT for this graph is basically 1.81 multiplied by 10 power of -4. This is in units, pound per Newton per seconds. So next, for the accelerated performance. First of all, in this section, I will calculate the takeoff distance. So in this figure, so I will calculate first the SA distance, and then plus with SG distance. To find SG distance, I need to find R first for the radius, and then use the cos and tan formula. So basically, this is all the formula I use. And for the SG, I get 367.5 feet, and for SA, I get 726 feet, and then I plus, and the total takeoff distance I get 4,401.5 feet. So move on to the landing distance. Basically, the idea is same like the F-curve distance, and because of I need to plus SA, which is approach distance, flare distance, and ground. And I also, and for this calculation, I assume the degree at A, this point are 3 degree. And for the obstacle are 50 feet. So I apply all these equation and get SA is 787.7 feet. For SF is 302.9 feet. And finally, as ground rule is 1,755 feet. So total of this component are 2,869 feet. So that is the climb 1,140 feet per minute compared to the general climb rate at Google. It have a difference value, but this value are acceptable because it is not too small and large. And when I get the climb rate, I can also calculate the climb time, which is at 13.7 minutes. So last but not least, the final component that I analyze is maximum turn rates. So let's and get the maximum turn rates at 9.98 degree per second. So first of all, I need to find the velocity at maximum turn rate and then apply into this formula and get the answer. So that's all for my